All right, so we're going to be talking about from description design to design using text-to-image models in your business. So what are diffusion models? So on the left, we have Théâtre d'Opéra Spatial by Jason Allen. This won first place in the digital category at the Colorado State Fair, and this image was generated by artificial intelligence. It was generated by a model called Stable Diffusion, which we'll talk about later. And the one on the right is Lensa AI. So it's an app that produces selfies that were styled by AI. And so both of these pictures were created using something called a diffusion model. So why is it called diffusion? Because it's based on a physical principle called thermal diffusion. So imagine that you have an aquarium and you put a heating element underneath it. You'll see the heat rising up on the left. There's a little bit of heat, and then there's more heat, and then up at the end, the water is saturated with heat. It's not going to get any hotter because it's kind of at equilibrium. Like the heater is still heating the water, but it's cooling at a rate so that, it's not going to get any hotter. It's not going to get any colder. It's reached kind of an equilibrium. And that's what thermal diffusion is, the movement of heat through a substance. So with image diffusion, it's a little bit different because we have an image, and instead of adding heat, we add garbage, we add noise. So we've got that first image where it's completely clear, and then we add a little bit of garbage, and then a little more garbage, and then at the end, we've reached the saturation point where we can add more garbage to it, but it's just still going to be garbage. So we could put that in terms of percentages instead of steps. We could go 0% garbage, 50%, 75, 100. So how this works from an AI perspective is you put in this image, like we took a normal image of a cat, right? And then we added a bunch of garbage to it. And then we say, okay, so this image is 75% garbage. And we also tell it, hey, this is a cat. And then we tell the AI, this is what the garbage looks like. So all of this is inputs into the model, and we're training it, right? So then we don't do that with just one image. We do that with millions of images. We just say the word cat, and then we have all these images, and then we have the percentage of garbage that we put into the image, and then we have the resulting garbage on the outside. So after we do this, we should have a perfectly trained garbage detector, right? If we put an image with a bunch of garbage in it, and then we say this image is 50% garbage and it's a cat, then our AI should be able to predict from those three inputs exactly what the garbage looks like, right? We have a perfectly trained garbage detector. So now why would we ever want a garbage detector? Why does that matter? Because if you take a garbaged up image and you subtract out the garbage, then you get a normal image, just like this. See, we've got the garbage cat, then we subtract the garbage, and we get a normal cat image. So what we do with this is we kind of play a trick on the AI. We start out with a completely garbage image that has never ever been a real image. It's completely random. It's just all staticky. But we tell the AI, we say, hey, this used to be a real image, and it's 100% garbage, and it's a cat. So tell us where the garbage is in this image. And then the AI predicts, oh, I think the garbage is here. So then we take our original image, our completely random image, and then we subtract out the garbage that the AI predicted. And then we get, oh, well, I mean, you can't really tell what it is, but it's a little bit smeary thing, but it's something. So let's try it again. So we're going to add back 75% of the garbage, and we're going to say, okay, this is a cat. And then so the AI is going to say, okay, I am predicting that this part right here is the garbage. And so then we take that image that we input and we subtract the garbage, and it's something a little bit clearer. And so we repeat this process over and over and over again. Each time we're predicting the garbage, taking it out, putting a little bit back in, and then back and forth and back and forth. And then eventually we get an image that looks like this. And this is not a real cat. This cat has never existed. This is an image created using that exact same process that I just described. And you can see down here in the corner, that is a watermark from OpenAI's Dall-e program. They put that down there because they don't want it to be misused. All right, so just to summarize, you start out with a completely random noise image, and then you clarify it through the process of diffusion that we just explained. Okay, so I need a prompt from somebody in the audience. Describe an image for me, and by the end of this presentation, I will generate one. Yes?
Cat walking, 3 dogs to the candy store.
Okay. All right, let's see if we can do that. Oh. a cat walking 3 dogs to the candy store. Okay, let's go back to here. Okay, so let's talk about the history of AI art. So way back in ancient history, long, long ago, before we had, text to image, back in the dark ages of December of 2019, this was how you did AI art. You would select which part of a model you wanted to visualize, which specific neuron you wanted to visualize. So these are what neurons look like inside of an image AI. And there isn't a lot of expression that I can do with this because, number one is I just put in the number 27. And then the next one I put in like the number 18. And then the next one was like the number 38, right? So there's no expression here. I can't put in any words. It's just numbers. And I thought it looked really nice when I made it. And then along came promptism, or converting text into images. And this is a prompt that I like. It's called the Saint of Uncertainty. And I'm going to show you how that one prompt has performed across many different versions of AI text to image programs. So this is Aleph to image. This was one of the first open source ones. Just a bunch of people on the internet just put this together and put it out. And so you can see how you have maybe a face here. You've got some saintly robes. Over here, what I really like about this is it looks like a stock market chart. And the stock market is uncertain, so it kind of got the Saint of Uncertainty, which is cool. So then the sequel to this was Aleph 3 image, which came out a couple months later, and it was a little bit better. You can see a face, you can see eyes, a nose, little mouth there. There's a lot of green and I think 4-leaf clovers, so maybe it was thinking like maybe St. Patrick. Then in October of 2021, a nonprofit called Stability AI released their own model. It was trained on millions of images. It cost them $100,000, and they just said, here, internet, you have it. And so, you know what? Actually, I skipped one. There we are. This is Stable Diffusion. This is what it looks like. And so I put in the Saint of Uncertainty, and you can very clearly see the eyes. You can see the eyebrows, the facial hair. There's a halo in the background and some robes. It's even got some letters. You can see the Saint of, and then it kind of messes up. These image text-to-image libraries, they don't work very well on text yet. So before that, there was one called Disco Diffusion. Again, this was open source and probably made by the same people. And it's called Disco Diffusion because it's not just one model. It's 5 or 6 different models, and you can choose which ones you use. And so this one has, he's got eyes. He's got maybe like a hat, maybe like Martin Luther's hat or like a monk hat. Maybe there's heaven in the background. It's not super clear. Then in November of 2022, just a few months ago, Dall-e 2 was released. This is made by OpenAI, who also made ChatGPT. So I like this model because it's more photorealistic. You can look at this and it looks like a statue. There's a halo, there's a face, he's got robes. It looks like he's made of concrete, and he's got some kind of maybe artifact, maybe like a cross in his arms. So also that same month, Stable Diffusion came out, or Stable Diffusion 2 came out, which is the sequel to Stable Diffusion, which we talked about before, where the company just released this model to the internet. And now I'm about to show you where things are now, February of 2023. This is Midjourney. This is the state-of-the-art model. And I really love this image because not only is it really beautiful and stylized, I love it because to me, it tells a story. It looks like this guy is like a priest with a really sketchy background. Like maybe he was an assassin or something. I want to watch a movie about this guy. I think he looks really, really cool. And here is another example. Vibrant, colorful, abstract painting with geometric shapes. Dinosaur eye with heterochromatia, intricate high detail. And this was... this prompt was actually generated by ChatGPT. Like I've made thousands of images, and some days I get, bored. I run out of inspiration, and so I go to ChatGPT and I say, hey, give me a description for a beautiful image. And this is one of the descriptions: a colorful and vibrant carnival scene with circus tents and balloons. And so now to the business applications. I mean, this is an enterprise conference. You guys are like, oh, this is cool, but how do I use this in my business? Well, there are a couple applications. First and most obvious is you can make art and you can sell it. It's also being used in product design. This was a prompt that I put in. I think I put in like a really beautiful supercar. And so this is a supercar that has never existed. It may look like other supercars, but there isn't one like it in the world. Another thing that I've seen people doing is designing entire app interfaces or websites using this tool. Like this is a design. People will turn this in and say, hey, make your website look like this. And that's a whole profession. And then the programmers actually implement that. But so you can come up with designs using this tool. Oh, this is really cool. This just came out yesterday. So there are doctors who, let's say that you have a rare disease that can be seen through x-rays, but there are only 10 people in the world who have that disease, right? And let's say I want to make an AI model that detects that disease from x-rays. The problem is an AI model requires tens of thousands of images, and there are only maybe like 50 real images in existence of this disease, right? Only maybe 50 real x-rays. So what they're doing is they're using diffusion, these models, to create new x-rays like this of the disease. They'll say, show me an x-ray of a person's chest who has this particular disease. So then they can create those tens of thousands of images and then feed them into an AI that they train to recognize that disease. So I just think that's a really cool application for this text-to-image AI. There are some limitations, though. It's really bad at hands. Like, if you look at this, the prompt for this was a person's hand, and this one has 6 fingers, and they're collapsed in on themselves. This one has, I don't even know. But yeah, this hand is horribly mangled, and it is really bad at teeth. So this girl looks beautiful, right? Until you zoom in on her teeth. You see her nose is pointing that way, and her teeth are pointing that way. And that's a really common thing. Like, I think every AI model that generates images of people that I've seen has this exact same problem, where the teeth will be off that way and the nose will be off that way for some reason. Okay, so in the future, we'll probably see this same model, these types of models being used for generating music and also videos. There's one now called Diffusion. It's not super great, but what they do is they convert music into images and then they train the model. And then you can put in a prompt of the kind of music you want to hear. Like, give me a jazz solo. And then it'll pop out an image, which converts back into music. And then you hear it and it kind of sounds like a jazz solo. All right, and we'll also hopefully be able to do time series data, like give me a stock market chart that's going down. And I read that somebody thinks that this kind of diffusion might be able to predict things. I'm not sure if that's true. All right, and let us take a look at the image that came back up. Here we are. As I remember, it was a cat walking 3 dogs to the candy store. And here we have a cat, and we have 3 dogs, and we have a candy store. And here we have a dog and 3 cats in a candy store. So it's the logic isn't always perfect. And that's a cat, and that's a dog. And so the interesting thing about Midjourney is if I like any of these, I can make it bigger. So let's say I like number 1. I can go back here, and I can click on upscale, and it will make that one larger. Or I can just re-roll and do the same prompt again. Okay, so what questions do we have? Oh, thank you.